Hi friends, remember when we talked about finding square roots and evaluating square roots, and we were always taking the square roots of positive numbers. Now I didn't point out at that time that all of them were positive, but I am now because we're going to talk about finding the square root of a negative number. Now, this is complex numbers, and I'm going to get back to that concept. Let's first talk about what we're really looking at. So let's say that I write down the square root of -4. Remember, when we take a square root, we're asking ourselves, what number multiplies by itself to give us -4? Well, okay, I know that 2 times 2 gives me +4, and I know that -2 times -2 also gives me +4. So what number could possibly give -4 when we multiply by itself? That's where we get into complex numbers. All right, so I'm going to give you a fact, and it's going to look a little bit strange. I'm going to ask you to stay with me here and just accept this as a fact. If I want to find the square root of -1, we define this as the lowercase letter I. And this allows us to work with what's called complex numbers. And you notice that this tells me about a square root of a negative number. So if the square root of -1 is equal to I, the second thing I know is that I squared is equal to -1. See how I just took both sides of this and squared them to get this fact? All right, so we can apply this going back to my first example of square root of -4. So remember, we can split up square roots. If it's -4, I can rewrite this as the square root of -1 times the square root of 4. And in place of the square root of -1, I'm going to use this cool fact right here. And in place of square root of -1, I'm going to write I. I'm going to do it right underneath it so that we can see where everything came from. And then in place of the square root of 4, well, we know what that is. Square root of 4 is just 2. So now instead of square root of -4, I have I times 2. And convention says we write the number part first. I'm going to write this as 2I. Now, you might say, well, Wendy, cool, you made up math and now you used it to create something that I don't know what it is. That would be a fair statement. 2I is an example of a complex number. And a complex number is going to have an I piece to it. Now, we use complex numbers with electronics, and there's some applications of complex numbers. Right now in college algebra, being able to manipulate them and use them is the basis we need so that you could use them in your future science courses. So a complex number, it might be in the form A plus BI, where we call A the real part and BI is the complex part. So this is a completely different group of numbers than you've dealt with before. Congratulations, you found new numbers. And it has its own set of rules. But the truth is, in most situations, we treat that I the same way we would any other variable. When we're multiplying, adding, subtracting, that I is going to be treated mainly according to the same rules as any other variable. In this video, I want to talk about simplifying a negative square root using complex numbers. Now, if this feels like a new idea, it is. So hang on, and the more you work with it, the more comfortable you're going to be. All right, so let's look at a couple of examples. Let me throw those up on the board. All right, let's look at some examples. So we're going to start with the square root of -9. Now remember, I need to break this up into square root of 1 and square root of 9, and then evaluate both of those separately. So square root of -1 times the square root of 9. Now I know from my fact over here that the square root of -1 is just I. So I'm going to write an I underneath it. Now square root of -9, we evaluate that using our square root skills from a few videos past. And if that feels unfamiliar, please go back to the video on simplifying square roots and review that before you move forward with this video. All right, so when we look at square root of 9, we know that's one of our perfect squares, and that the square root of 9 is 3. So I have I times 3, and remember, convention tells us we write it as 3i. I times 3 is not wrong, it's just not the way we tend to write it. All right, let's look at another one. Square root of -20. Again, the first thing I'll do is break it up into square root of -1 times square root of 20. I know that the square root of -1 is I. Then we have to deal with that square root of 20. So square root of 20, I'm going to rewrite as square root of 4 times square root of 5. Because once it's broken up into these two pieces, we evaluate that just the way we would if it were square root of 20 from the beginning. All right, square root of 4 is 2. I'm going to leave this in the same order. So I have I times 2 times square root of 5. And I'm going to do that so that I don't lose anything. And then at the end, I'll write it in the proper order. All right, square root of 5 is as simplified as it can get. So we're done, except for putting it in the right order. Now, when we deal with a square root and a number and an I, we start with the number. So I'll write down the 2. The I gets sandwiched between the number and the square root. So we would write that as 2i square root of 5. Occasionally, you will also see this written as 2 square root of 5 times I. Now, that happens rarer, and the reason for that is it's hard to tell if the square root symbol extends over the I or not. It can be confusing. And so generally, you will see it written as 2i square root of 5, but I want you to know this is also correct. Okay, so just like when we have a variable and a number and a square root, that variable goes in between the number and the square root. All right, let's try another one. Square root of -108. All right, so this would be square root of -1 times the square root of 108. 108 that's a pretty big number. I'm going to use a factor tree to simplify that. I'm going to just put that right over here. So 108, well, I know it's even, so I can rewrite that as 2 times 54. 54, that one's, let's see, 9 times 6. I know 9 is 3 times 3, and 6 is 3 times 2. Okay, so I'm looking for pairs of numbers. I have a pair of 2s that I'm going to circle, and then I have a pair of 3s that I'm going to circle. What's left is just that 3. Okay, so in place of square root of 108, I'm going to rewrite this as 3 times 2 square root of 3. Now, if this felt unfamiliar, please go back to the video of an alternate method for evaluating square roots. And I tend to use that method when the numbers are larger, or there's not an obvious perfect square factor. All right, in place of that -1, of course, square root of -1, I'm going to write an I. So I have I times 3 times 2, square root of 3. I'll combine the 3 and 2 together to have 6. And then we have 6i square root of 3. Okay? For the last one, I put some x's in there for your own good. All right, we're going to break this up 3 ways. It's square root of -72x squared. So the first thing I'll write down is square root of -1, and that's for that negative. This is multiplied by the square root of 72, which is multiplied by the square root of x squared. Now remember, when we were evaluating square roots that involved variables, we rewrote it as the square root of the number part times the square root of the variable part. Because there's a negative, now it's in 3 pieces. So in place of the square root of -1, I'm going to write an I because of my fact over here in the box. Now let's look at that square root of 72. Well, I know that square root of 72 is square root of 36 times the square root of 2, because 72 is 36 times 2. And then finally, let's look at that square root of x squared. Remember, that's one of the facts that we want to keep in mind, is that square root of x squared is just equal to x. All right, so I have I times square root of 36 times square root of 2 times x. Checking through that, I can evaluate square root of 36. That's just equal to 6. So I have I times 6 times square root of 2 times x. Now that answer is technically correct, but it's in the wrong order. So we're going to rearrange it to be conventional. But I want you to know that that answer is correct. It just looks funny. All right, numbers on the front. So I could write it as 6xi square root of 2. Occasionally, you will see it as 6x square root of 2i. And unfortunately, you could also see it as 6xi square root of 2. So all of those are technically correct. It's a little confusing that it could go either way, but I do want you to know that if your answer is in any of those forms, it is correct. All right, in the next video, we're going to talk about adding, subtracting, multiplying, and dividing complex numbers.